Hi Year 12, I'm going to be explaining how I have done this first mechanics problem on a pulley system. So I'm going to first talk you through the key parts of the question that you need to watch out for, and then I will go through my working out. So first of all, you're told that you have two different particles of two different masses, particle A and particle B. You are told that the mass of particle B, which is your M, is less than 2. That is a piece of information that is really important, because if we know that the mass of A is 2 kilograms and the mass of B is less than 2 kilograms, that must then mean that A is heavier than B, and therefore my pulley system is going to move down in this direction. It's always going to move towards the heavier object. Therefore, it's going to move down in this direction on the left-hand side and upwards on the right-hand side. That will become really important in a minute when we set up our F equals M times A equation. So what I've done down here is I've redrawn my diagram. It's not perfect, but it will do the job. I've drawn in the tension in the cord or cable. I have done my double arrows to show which way the objects are accelerating. I've indicated how far away from the ground object A is. We're told that right up here. You don't have to include that in your diagram if you don't want to. It's just for my own personal use. And then finally, I have included the other forces that are acting on the objects, which is the force of weight. Remember that your weight is always your mass in kilograms times by g, which is 9.8 meters per second squared. So in this case, I've got a weight of 2g and a weight of mg. So in part A, they're asking me to show the acceleration of A as it descends is 0.96 meters per second squared. What I know is that my object starts from rest. I'm told that here. And it takes 2.5 seconds to hit the ground. So my time is 2.5 seconds. My initial velocity is 0 meters per second, and the displacement is 3 meters because I was told that my object was 3 meters above the ground. So it's taking 2.5 seconds to hit the ground. From there, all I've got to do is find my A, which means I'm going to go to my SUVAT formula. I'm going to pick the one that has the S, the 2, the U, and the A in it, which happens to be this one here. So S equals UT plus half AT squared. I'm going to substitute in my values and work out my A, which is 0.96 meters per second squared. So I'm just going to leave that up there for a minute, and if you want to pause on that, you can. That is part A done. In part B, you are asked to show that the mass of B is 1.64 kilograms. So this is where I would look at my diagram and think about what I now know. I now know that my acceleration here and here is 0.96 meters per second squared. I know that I've got some forces of weight and tension acting on my object, so I'm going to use my F equals M times A. And I'm going to do two separate equations, one for particle A and one for particle B. So for particle A, the total forces acting on this particle is my weight and my tension, remembering that we always accelerate towards the bigger force. If we're accelerating down this way, that must mean that our weight is bigger than our tension. So I've got 2g minus t is equal to 2 times by my acceleration, which is 0.96. And I've rearranged that to find that my tension is 17.68 newtons. Going back to the question, it is asking me about the mass of B, so I need to keep going. I've formed an equation here with my F equals M times A for particle B. In this case, particle B is moving up, which means that the bigger force is the tension and not the weight. So this time my F is going to be T take away mg. And then I've got my mass, my mass times my acceleration, which is m times 0.96. All I'm then going to do is I'm going to rearrange and solve for my m here. Now don't forget that g has a value of 9.8, which I've substituted in there, and I've just rearranged to find that the mass is approximately 1.64 kilograms. So again, I'm just going to stop there. You can pause that if you'd like and look at my working out. That is the answer to part B. And finally, part C. You will often get this type of question in an exam, and the answer is always the same, but I'm going to talk you through why the answer is what it is. So it's asking us to explain how we've used the information that the string is inextensible. So first of all, you need to understand that inextensible essentially means there's no stretch to the string. So in other words, it's taut. The reason why that's really important is that if my string doesn't have any stretch to it, the tension here and the tension here is going to be the same. It's going to be constant. If the tensions are the same and my masses and therefore my weights are not going to change, the tension and the weights are both the same, meaning the total forces on each object are constant. That then means that my acceleration is the same. So in other words, If my string wasn't inextensible, if there was some stretch to it, the tensions would not be the same on either side, and therefore I wouldn't be able to use the same acceleration for particle A as I did for particle B. So all you really need to say for this question is that because the string is inextensible, the acceleration in both particles will be the same. If you say that, you're going to get the mark. It's that simple.